Anyway, linear functions, to me, the most we use them is for statistics. We make prediction lines out of them. So we look at data and we see if when one thing grows, does the other thing grow? Or if one thing increases, does the other decrease? And then we make predictions based on that. That is used all the time. Okay? Linear regression is what it's called. It's used in statistics. It's used to make predictions. They use past history to try to predict what's going to happen in the future. Okay? That is what is used a ton in our world. So to understand what a linear function is important because it's how a lot of predictions are made. Okay? Predictions with cancers and how long you live based on things, just the past statistics of how long people live with certain things. So like my mom on Saturday a couple weeks ago had a bleed. It was in her brainstem. That is not a good place to have a bleed because your brainstem is what controls all your breathing, all of that stuff. Okay. They came to me and they said, based on past experience, linear regression, she'll probably live about 24 hours. They were 1 hour off. She lived 23. I mean, that's how close it is. And so that though, it's just an example of how did they know that? Because other people that have had the same types of bleeds, they've looked at the data and said, based on that, this is probably what's going to happen. Yes, everybody's individual, but for the most part, that's about what it's going to be. So they can predict it. It's just like when they give certain people certain amounts of times to live when they are diagnosed with cancer. They know, based on past experience with past patients, what's going to happen. Do people go different amounts? Yes, they do. That's variation in that. But statistics takes it and kind of puts it on an average. And that's how they make those kind of things where they can say, you probably have about 6 months. And they know this just because of past history. But they did a linear regression on that. The symptoms you're having right now, the things we know about your condition right now, based on that, we can say this is going to be what happens. And so that's how we use linear functions. So that's used all the time. It's used if you have a child to predict to see if your child is gaining enough weight to be growing, because your child should grow so much over the time. Okay? They expect a child to lose a little weight the first week or two, and then they start growing. And if they're not growing at a certain pace, they're going to look to see what's going on. Is there not enough food? Is there not, what's happening here? Okay, so those are all linear predictions. You will see those over and over and over again. Okay. The quadratic function, we talked about that last year if you weren't in here, but it's used really to predict how balls fly, how torpedoes fly, how missiles fly, how it's any projectile moving. That is one that's really how it's used for. The other big way it's used is in satellite dishes. Satellite dishes are actually paraboloids, which means it's a three-dimensional figure of a parabola. And depending on how the shape of that depends on how far away they can get, what frequencies they can get. So it's all based on the quadratic function. Okay, so every time you use or your GPS, which is satellite based, you're using some sort of quadratic there. They figured out what the quadratic is, so you can receive that signal. Okay, that's how it's been used. Okay, very important in military operations, because if we're trying to shoot down or trying to shoot something without getting close, we use a quadratic. Exponential, absolutely used in finance. It is the biggest one that's used in finance for calculating loans, calculating interest, calculating inflation, calculating all sorts of things. It's usually called the growth function. So it is also used to show growth of, excuse me, populations. Like I said, it's limited in that, but it does show some growth in populations of animals, humans, all sorts of things. It shows growth sometimes as a child, you grow exponentially, okay? Not as an adult, but as a child, you actually grow exponentially because you are growing so fast. Your body is growing so fast. Think of a little baby, and within a year, how big they are. That's an exponential growth. Okay, they start out a little bit slower. Right when they come out of the womb, they don't grow real fast, but then it grows faster and faster and faster, usually through the first year to 2 years. Then it kind of slows down. And so we have a slower growth. But exponentially, that is what we're looking at. Okay. Absolute value function. I don't know what we use that for, to be honest, except for when we want positive numbers, distances. If we're talking about distances, that's when it's used. It's mainly taught just so that you can see different translations, I think, because I don't see a real definite way where we use that one that often. Okay, it's kind of like the cubic function. I don't really know where we use a cubic function that much. That's why, to me, these three here are your most important functions because they are used the most. I see them the most in the world around us. Okay, and so that's why algebra centers on those. Again, if I were to revamp the curriculum, I would revamp it quite differently than what I have to teach you according to the Washington State law. Okay, because I think that doing things by hand nowadays is not that important, but learning how these can be used or where they're used is much more important so that you can understand at least some of the things that are going on. Okay, so that's basic, kind of the basic function idea. Again, these are all functions. One way we can tell is if I just think about, it's called the vertical line test. If you can put a line anywhere in the function and it doesn't cross 2 points, it's a function, okay? Like here, just only crosses one spot. Doesn't matter where I put it, it only crosses one spot. Here, the way I've drawn it, it should be crossing in one spot. Again, this one is not drawn perfectly because I screwed it back in, but it only crosses one spot when you do that test. Okay, here, vertical line test shows. If I put a vertical line, there's only one answer. That's just showing that for every X that you put in, you get only one output. Okay. Now, the horizontal line test tells you if you have an inverse that's a function. Okay. If you go like this, that does not have a function that's an inverse because it's going to have now inverses when I flip those two numbers. I flip the X and the Y. Okay. This is going to tell me there's no function. There is still a number, some stuff, but there's no function because we're going to get two outputs. Okay. Same with this one. No function, that is its inverse. It does not have an inverse. That is a function. Has an inverse, but it doesn't have one that's a function, okay, that gives you just one value. It gives you two values. So that's the thing there. Okay, so now let's look at some translations. We are going to use, I think we'll use the quadratic right now, okay? We are not going to talk about changing the size of it, Okay, that's different. We are going to keep the quadratic function looking identical to what its basic function is, but we are going to rotate it. We are going to, well, we'll do several different things with it, okay? And then we're going to do it with different ones. Okay, so when you're looking at the quadratic function, and this is handy when you're looking at these, to have some of the basic numbers that we have down, okay? So we're looking at a quadratic function. The basic function is y equals x squared. Okay, that's our basic function. If I were to look at some points on our function, oops, first thing I'm gonna do is make a chart. Sometimes it's easier just to see with a chart, okay? I'm gonna use -2, -1, 0, 1, and 2, okay? This is our basic function. These are graphs of that, or numbers on that basic function. This is x squared. So this equals x squared, so this is -2 squared. So my y value is 4. This is -1 squared, my y value is 1. This is 0 squared, my y value is 0. This is 1 squared, again 1. 2 squared, which is 4. Notice these become positive because when I square a -2 times a -2 is a positive 4. Okay? Hence, when we graph it, ooh, that's a pretty line. I don't even need this lower part. Oh, yes, I will. Sorry. I will need that. Okay, so when I graph it, I go through 0, 0. I have 1, 1 right here, both sides. Let's see, that's 2, 3, 4. 4. So my basic function looks something like that. So that's the base function. Okay. So that's the base function. We can translate that. If you remember back in algebra, you may not. That's why I'm going to go over it. But in algebra, we added numbers to translate. Okay, so I'm going to start with 1. If I take this equation and I add a number at the end, like 3, okay, if I add that number at the end after the x squared, it moves it up. Because watch what happens. If I take this answer and add 3, now I have 7. If I take this answer and add 3, I now have 4. If I take this answer and add 3, I now have 3. If I take this answer and add 3, I now have 4. So if you plot those, notice it's 3. We're out at, let's see, where am I? 4 right here. And then we're going to be up at, let's see, that's 4, 5, 6, 7. Now we're going to be at 7. There, all it did was move it up 4. Okay, so an addition of a number moves it up if positive and moves it down if negative. Okay, so let's just do y equals x squared minus 2. Okay, x squared minus 2. Well, if you look at my original equation, I'm going to put it in a different color. I have some really nice different colors in here. An orange. Let's see if my orange works. Okay, if I now change it, we're going to go from this original again. We're going to subtract 2, so I take this and subtract 2, so I get 2. Subtract 2, I get negative 1. Subtract 2, I get negative 2. Subtract 2, I get negative 1. Subtract 2, I get 2. So my new graph, this color, okay, is going to be down 2, because it starts down 2. So it's going to be at negative 2 here. At 1, it's going to be at, that's a weird sound. Wow, that got not orange anymore. Okay. And then at here, it's going to be at 2, which would be basically right there. So notice my function moved down. Okay. That is true of any function. Any function I give you. Okay. Any function that I give you. If I add or subtract a number at the end of the original function, it moves it up or down. It's a translation up or down. So if I wrote y equals x cubed minus 3, that's going to take the x cubed, the little SE1, and move it down 3. This translates the function up or down, depending if it's positive or negative. Yes?
Isn't it called the y-intercept?
Well, in this basic function, yes, in most of these, but if I move it vertically or horizontally, left or right, it's no longer going to be the y-intercept. Yeah, but you're correct, it is right now. On the base function, it really is, okay? It's the same thing if I do y equals x minus 4. If you think about that, it really just takes this would end up being like this. So instead of being like that, it would be down at negative 4 and it would be parallel. So that negative 4, that number we add at the end, just moves the function up or down. Same thing with exponential. If I add a number at the end, so it's like this. Different color. Y equals 2x minus 4. It is at the end. Notice the 2x stays the same. Okay. This will move my exponential function down 4. It translates it down 4 because it's a negative. If it were y equals 2x to the positive 2, that would move it up 2 spaces. So the picture doesn't change, the graph doesn't change, it just moves up 2. So that's the translation that's up and down. Okay, so that's the easiest one. Well, mostly. Okay, so that moves it up or down. That's our up and down translation. It's always that number that's added at the end of the function. It's not added inside the function, it's added at the end of the function. Okay, so the thing, that's what moves it up or down. The thing that moves it to the left or right, and this one gets a little bit tricky, is the one inside the function. Okay, when I add a number inside the function, what that means is if we have y equals x squared, okay? If instead I add, see inside the function, see this x is inside the square? Okay. X is being squared. If I add a number inside where x is, so I make it -1, this is going to move it left or right. And when it moves it left or right, it's opposite of what you think. Okay. I'm going to take this for a minute right now. We're going to go back through and just show you why it works that way. So now we're putting in a -1. It's not a -1 of this number. Oops, I should have left those numbers there. This was my original function. I wish I could pull these off faster. 4, 1, 0, 1, and 4. Now I'm going to take and we're going to make y equals x -1 and we're going to square it. Okay, let's see what happens to our answers. So now I take -2, subtract 1, get -3, square -3, and what do I get? I get 9. Is that correct? Okay. If I take -1 and subtract 1, I get -2. -2 squared is 4. Right. If I take 0 and subtract 1, I get -1. -1 squared is 1. If I take -1 and subtract 1, 0 squared is 0. And if I take 2 and subtract it, I'll get 1. Do you notice that these have shifted? See how my 0 shifted down? The 1 shifted down here. So here was 1, it shifted down, 0 shifted down, 1 shifted down, 4 shifted down. Okay. So what's actually happening there is if I look at it, I'm going to have at 0, there's going to be 1. So that's going to be right there. Here, 1 is going to be 0. 2 is going to be 1. And it will go up basically like this. Notice did I do that wrong? No, I didn't do that wrong. Okay. It shifted it 1. Why am I thinking that should be -2 is 9. Okay. -1 is 4. 0 is 1. Wait. 0 is 1. 1 is 0. Wait a minute, I did this backwards. You guys let me do this backwards. I didn't graph those right. You guys didn't even catch me. 1 is 0, not -1. 1 is 0. 0 is 1. I had that one right. -1 is 4. 4. This is going to be 1, and this is going to be 4. Notice, there you go. This is the way I wanted it to shift. When I have a -1 in there, notice it shifted to the right. So it shifts the opposite that you would think. It shifts the opposite. So if it's to the left, that way, it's when it's a positive number. If it's a negative number, then it's going to shift it to the right. So that's our translation. That's the thing that's a little backwards. Okay? That's the thing that's a little backwards to us, but that's how it actually works. So in any function, if I do y equals x minus 3 absolute value, this is gonna move it 3 places to the right, your basic function, 3 steps to the right. Okay, so anything inside like that will shift it 3 sections to the right. Okay. I think we have a need of a break, because I need a break. And so let's go ahead and we'll meet back at 5 till. Okay?
Yes. 10 minutes on that.
If you have your notes from the video that I made, please put them out so I can look at them as I go around. Notes from the video that you were to watch.
What video?
What video? Well, ask your parents, because I sent them actually
Oh, really?
a note saying that I was doing it. I sent you guys an email saying
what's
I
on the
was doing
notes?
it.
I get so many emails.
Is this how to do those
Transformers.
things?
It's part of what you need to do though.
Like the movie.
Do they send like
Watch the
Skip read them there like
I didn't check my school email in like 5 months.
Yeah, you're screwed.
If it doesn't show up in classroom, if you don't say it first,
I'm not seeing them.
I have everything.
I was
Okay,
just
good.
wondering about projects and stuff
Okay.
that really counts. I can take the notes,
Wait, is this the one?
you know,
Yeah, that's it.
Oh, yeah.
like I've taken some of the notes, so I don't think that
Who's
they-
next to you?
but
Wait a minute. Maybe.
Yeah.
I
Yeah.
really was focusing on getting.
No,
could use
it's
notes.
that, it's a translation.
Other things.
Wait, what notes is this that you want?
It's the one where you were, so that you were to do the worksheets afterward, there was a video I posted for you to watch, and it even says in there, please take notes on that video. None?
I remember I did do them for sure. That's why I could have a
You
few
take
for
any
seconds.
notes? Good job. I'll write down who did them this time,
I
because
might
it's
be
easy.
going to go see Hitler's Tea House soon.
Hitler's tea room.
Like the original?
Yes, yes.
Like, do we like live in a tea house or something?
Oh, he had a private tea
Okay.
house somewhere in Austria.
Like, was
Are you
it
gonna go to
running-
Austria?
Was he running the shop or was that like?
Oh no, I'm sure he probably just got it because he
Got
bought it.
pushed.
No,
He's
probably-
too lazy to buy it.
No,
He
probably
took it.
just went there like a
I
private
know how
house.
things get pushed, believe me.
Okay.
Yeah, he had several different houses. He had one in like the Alps.
is in like,
He had what was it?
Yeah.
and not like a tea shop.
Didn't he call it like the Eagle's Nest or something in the Alps?
No, good.
And he ended
Organization.
up raiding it in 1945.
Strive for that.
Parachuted in there and raided it. I don't think he was there though.
Going to.
By that point, he was killing himself.
Who is killing himself?
Hitler.
Stapled into the
I'm
very.
Yes,
just here.
please. Actually, put it over there. I was
Well,
trying to
my
keep
mom
them
had
separate
a
from the
Czech Republic
worksheets.
to get her eyes fixed.
Can do it here.
No,
Do we have
she wants to do it there.